We're going to talk about end behavior with polynomials. And the typical polynomial in general form is ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus ... and some final constant k as we get down to just a simple number. End behavior is going to focus on this very first term because it doesn't matter what these other terms do. It doesn't matter how big b or c is. This x to the biggest exponent that we have is going to take over everything else. For example, if I have x to the fifth minus 2,000 x to the fourth plus 3x cubed plus ... something. It doesn't matter. This number seems really big to us. Doesn't matter. Eventually, this guy is going to get bigger than anything else as x gets large. And that's what we talk about with end behavior. We're talking about what happens to this function out at the extremes, where x gets very large positively or very large negatively. So we're going to look, always when we do end behavior, we look at that very first term. So let's suppose I have negative 4x to the fourth minus 2x squared plus 3 as my polynomial f of x. I guess the book has been doing p of x for the word polynomial, but it's just a letter. I'm going to go back with f of x because you're used to functions and I'm used to functions, and that's what we have here. If I have this term with an even exponent, it doesn't matter what value I put in for x, x to the fourth is going to be positive. Doesn't matter whether x is small or x is large, x to the fourth will always be a positive number. And thus, with this negative number around in front of it, this whole thing will always be negative. And so our function, whatever it is going to come up from below, do whatever it does, and then it's going to go back down again as x gets large positively. You see what I mean? That negative forces end behavior in the negative direction. The y value will be negative. Now, in the close part where we're close to the origin, these guys might take over. Well, no, it's I guess there's a little bit of a spot where that 3 might blow everything else out of the water and it might end up as a positive number. But I think probably I've drawn it pretty close to what we've got. 5x cubed plus 2x minus 3. I'm missing an x squared term. There's just a 0 in front of that. Here, our end behavior, when x is negative, x cubed will be negative because a negative times a negative times a negative is negative. Times the 5, I'm going to be coming up from below here, whatever happens. Now when x is positive, x cubed is positive, 5 times x cubed is going to be positive, and so my end behavior is going to be coming up from above there. Now what happens likely is some kind of thing like this in the middle, because cubics look like this. But end behavior-wise, you're going to see large negative numbers being very large negatively, large positive numbers being very large positively. to wrap up, what we're going to look at is the very first term of the polynomial, and we're going to look at exponent, odd or even. And then we're going to look at sign in front of the term. Those two things are going to determine what our end behavior is.